Hello guys, and welcome to the RS232 Crestron Independent Study tutorial. So I currently have the Hello World tutorial project open, so if you could go open that. I'm going to start with this code and then add to it. So currently we have the TouchPanel working from the last tutorial, and we have our Hello World code here, but now we're going to add RS232 control capability for the projector. So first thing that we need to do is declare a comport. So up here we're going to go private, and this is for RS232 controls. So we're going to call it's a comport, and call this comport. Perfect. And then next we are going to assign the comport to the actual port on the processor. So currently we just have an arbitrary comport. We need to assign it in the processor. So what we're going to do is to assign it, we're going to assign comport to comports sub 1. So now our comport variable is assigned to the value in the array of comports at index 1. Perfect. So now we need to register the comport similarly to how we registered the touch panel. Otherwise it won't work. There we go. And once it's registered, we need to set the comport spec. There's a method for that. But first, before we do that, I'm going to pull up Toolbox. Actually, excuse me, not Toolbox. We'll pull up Toolbox later. Currently, we need Simpl. Let me open Simpl. So there's specifications for how RS232 works, and so we need to find those settings in Simpl, and then we'll use those settings for the method in Simpl Sharp. So we'll let that load. But while we're letting that load, I'm just going to go comport dot set comport spec. And there's two versions of this method. It looks like it's overloaded, but we want this version. So we need to open Simpl to find the baud rate, the number of data bits, and all of these other values. I'm not going to read them all out, but we need to open Simpl to find all these values so we can initialize the comport. So Simpl looks like it's open, so we're going to open this project. If you go configure, so if you open Simpl and go to the device view and open the processor, and on slot 4 from a previous project we had a two-way serial driver, and so if we open properties on the serial driver we can see the baud rate and data bit information here. So this is all the information we need. So I'm going to close this, minimize this. So what we need to do for the baud rate, if you look in the documentation, you can't just pass an integer into the arguments for this method. You have to pass an enum. And so if you look at the documentation for the baud rate, we need to pass Crestron dot Simpl Sharp Pro dot comport dot ecom baud rates dot com spec baud rate 9600. Perfect. I'm going to make a new line just so this is easier to read. So it's giving us an error, of course, because we don't have the other arguments. So for our next argument, we need Crestron.simplesharppro.comport.ecom data bits. .comspec data bits 8. So if we open Simpl and go to configure, we can see we have 8 data bits for that. So we'll close that. Next we need Crestron.simplesharppro.comport. Our third argument is the parity type, and there's no parity. So I think it's ecom, no. ComSpec parity none. So we need ecom parity type, ecom oops, forgot the ecom parity type dot none. The next argument is the stop bits, and so if you remember from Simpl, that was just 1, so we need Crestron.simplesharppro.comport.ecom stop bits dot com spec stop bits 1. Perfect. And then next is our protocol type, which is RS232. So we'll just put that in. So Crestron.simplesharppro. Autocomplete in Visual Studio is not fun. Okay, SimpleSharp. We'll just go back to autocomplete. SimpleSharppro.comport. What did I say we need? Ecom protocol type. Ecom protocol type. .rs232. Apparently there are different protocols that we're not using, but we're using RS232 for this. Next is the hardware handshake. And if we go to Simpl and hit properties, there was no handshake. That's the hardware handshake, and this is the software handshake. There's none for both, so we'll put that in here. So we'll go down a line, Crestron.simplesharppro.comport. Hardware handshake is first, dot none, dot none, comma, Crestron.simplesharppro.comport.e software handshake type is none. Oops. Perfect. And then our last argument is false for the report CTS changes. And that's it. So that shouldn't throw any errors. Looks like I did this one wrong. Let's redo this. So dot 9600. Let's find it. Here we go. Great. So no errors. We'll save that. Okay, so now we've declared our comport. We have initialized it equal to the port on the processor. We've registered it, and we've set the specifications for the comport, which we found in Simpl. And again, we went in a previous project for this class. We opened this and went in the serial driver and hit configure, and all the device settings are here. So now that we've set the comport spec, now we need to be able to send strings over RS232. And so we're going to declare those as global constant variables. So you're going to have to look up the string value for your particular projector because each projector is different. And so after scouring the internet, we found the RS232 controls strings for our particular projector online. And so I'm going to enter those in here. So I'm going to declare those as global constant variables. So the first string that we need is the delimiter. And so the delimiter basically is the string that signals that we are done sending instructions and you can execute whatever we just sent you. It's kind of like the new line character, sort of. So we're going to declare a public const string. I'm going to call this projector delimiter string. And this is equal to backslash. This is going to be different for each projector that you use, but for our particular projector, it's backslash, lowercase x, 0, and uppercase D. Now I'm going to declare constant strings for each video source and for power on and power off. So after some testing, we found that VGA1 on this projector is this string. Give me 1 second. Oops, looks like I put string. Equals, it's source 10 with a space. So if you send this string and the delimiter after it to the projector will switch to VGA1. Again, you can find this in the user manual, or you might have to look a bit deeper on the internet for these strings for your particular projector. So I'm just going to paste this. VGA2 was source 20. HDMI was source 30. And then SVideo was source 40. Perfect. And then the power on and power off were quite similar. Oh, looks like I forgot projector, so I'm going to fix that. Perfect. And then projector. And then power on is just PWR space on, and off is the same way. Making const strings as global variables is useful in case your projector changes and you need to change your strings, and then you only need to change your strings at the top of the file instead of throughout the rest of the file multiple times at the same time later. So I'm going to save that. So now that we have our strings defined, now we can start writing our logic. But before we do that, I'm going to declare some more constant global variables, and these are going to be integers, and I'm going to declare some global integers for our digital values for our button mapping. It's much more easy to read. Projector VGA button, for example, instead of 10 or 9 or 8. It's much easier. You don't forget. So I'm going to declare some more variables here. I'm going to do a constant projector on button equals 6. And same thing for off. Off will be 7. And then I'll just copy this, and we'll make 4 more buttons for our various inputs. Projector, HDMI, but oop, I have caps lock on. VGA1, VGA2, and SVideo. And these just go in order, so that'll be 8, that'll be 9, that'll be 10, that'll be 11. So again, it's going to be much easier reading the code if we have these strings instead of, a number. Much easier to read the logic that way. So we're going to save that. Okay, so now that we've declared our global variables, we can start writing our logic, which isn't very hard to write. So we're going to go down here, and it looks like we still have our switch and case statements, which is perfect. So we're going to first write the logic for turning the projector on. So we're going to get rid of this. We don't need it. So if args.sig.number equals, it should be projector power on, I believe. Projector on button. So if our projector on button is pressed, then we are going to set the digital value for that to true. So that way, if there are multiple touch panels in a room, the other touch panel can read that digital value and know whether or not the button was pressed. So I'm going to do user interface .boolean input, and this is where our global variables up here are very helpful, because I know that projector on is 6, and so instead of putting 6, I'm just going to put projector on button. That's going to be set to true. Bool value. Bool value equals true. Great. So it likes that. So basically what we're doing is we're switching the type of change on the touch panel. If it's a Boolean, which means it's a digital change. If the change was actually made, we're checking if projector on button was changed, which is index 6. So if digital 6 was changed, we're setting digital 6 to true here, and then we're going to set digital 7 to off or to false, because digital 7 is the power off button. And so if we have multiple touch panels, we want any touch panel to know in the room whether projector is on and off, and it can do that by reading the digital value. And so since we only have a single touch panel for this class, we don't technically need to do this, but if this was actually being used in a classroom, you would want to be able to check the value. So this is going to be projector off button, which is index 7, bool value equals false. Perfect. And now we're going to send the string over RS232 to the projector. That's the last step in our process here for this if block. So Now that we've set digital 6 to true and digital 7 to false in case there are any additional touch panels in the room, now we can actually send the command to the projector. It's pretty easy. You just do comport.send, and then it just sends a string. So we're going to send projector power on string. Uh-oh. Looks like it's defined more than once. I'll go fix that in a second. Then we're going to add the delimiter. Perfect. And I'm going to go check that. That should be off. Perfect. So after checking our logic with the touch panels, in case we have more than one, we are sending the string to the projector with a delimiter at the end. And that's it. That should work. So I'm going to comment that this is projector on. Perfect. So now we can write our logic for off, which is very similar. So we're going to else if. I'm going to copy this and just change what it says. We're going to do else if projector off button. I'm just going to copy this code. And for this, I'm going to set this to false and this to true. Just switch those. And then we're just going to change that to off. Save. And we're going to comment. Easy. Okay. So now that we've done our projector on and off, now we need to be able to switch inputs on the projector. So that's fairly easy to do. We just need to make some more else if blocks. So we'll do else if, and then I'll paste this in. Get rid of that space here. Paste this in. Close that. Go down. Okay, so now we're going to do HDMI. And if it's HDMI, we want to set all of the digital values for all of the inputs to off. And then we'll set HDMI to true. Because we don't want more than one of them to be true at a time. So what I'm going to do is I'm going to make a simple function, a void function that just sets all four of these values to false. That should be very easy to do. So what I'm going to do is close this. Right here, we're going to add another function. Void. We're going to call this function set sources off. Set sources off. And in this, we're going to set our HDMI, VGA1, VGA2, and SVideo digital values in the array of digital values to false. Hopefully that makes sense. So we're going to do user interface. Actually, yeah, we're going to do user interface dot Boolean input projector HDMI button dot bool value equals false. And copy and paste this. VGA1 and SVideo. Save. Okay, so now if we call this method, it'll shut everything off for us instead of having to type it out manually each time. Perfect. So let's expand this again. So we're going to set all of our sources off, and then we're going to just copy this, set it to true. That way we don't have more than one source on at a time. Okay, so that looks like that should work. Oh, we didn't send the string yet. So now that we've done all of our logic for the touch panels, we're going to actually send our string. So comport.send projector HDMI string plus projector delimiter string. Oh. Close. Okay, so this is all of our logic for switching to the HDMI input on the projector, so we'll do HDMI. Perfect. Now we can just copy and paste this for everything else. So this one's going to be VGA 1. We'll paste that. Perfect. Get rid of that. Okay. And we're going to set VGA1 to true. And we're going to do VGA1 string here. Save that. Okay. Copy this. VGA2. VGA2 button. Just making sure it's recording. VGA2 button. And VGA2 string. And the delimiter. Great. Lastly, we need SVideo. Not that anyone uses SVideo anymore, but we can add that in. So the SVideo. Ooh, SVideo. Okay, so now our logic is there. So let's just go over our code again. So we declared a comport, we declared our constant global values for our buttons and our strings. That way we can change stuff later if needed. Let's say we wanted to remap these to something else. We could very easily do that up here. We initialized our comport to index 1 in the array of comports on the processor. I'm not sure exactly how that works. And then we registered, and then we set the specifications for the comport based on what we had in Simpl. We declared our set sources off method, which shuts everything off for us. And we wrote our logic here. And again, this logic here for each if-else block isn't needed with one touch panel. However, if there are multiple touch panels in a room, this logic would be necessary so that you could access, you could do a simple if statement and check what the current value is in case you have multiple touch panels. So we filled all this out, and I think that should work. So this code should work. So now we need to make our VT project and test it. So let's open VT. Okay. Make this a bit easier to read here. Let's open our tutorial project from last time, from the last video. We'll open page 1, make this full screen, make that full screen here. Okay, let's delete everything. Okay, so let's add, we need 6 buttons, 2 for power, 2 for power, 1 for power on, 1 for power off, and then 4 buttons for each of our inputs. So let's add some buttons here. We'll add a simple button. Let's put our power buttons here. Our sources on this side. Looks like they snap to the grid. Okay. Copy this. Okay, so let's expand this. And this will be power on. Actually, let's call this projector on. This will be projector off. This will be HDMI. This will be VGA 1. And SVideo. Okay, so now we can go back to our Visual Studio project and see what everything is. Okay, so on is 6, off is 7, and then 8 through 11. That's pretty easy. So we can go back here. This is going to be 6, so we want enable digital join to be 6 on this one. On projector power on, so that should be 6. Off is 7. Actually, I think it should be, it might be press digital join, but let's just try this. 8. Cool. So it looks like this should work. Oh, you know what, it is supposed to be press digital join. My bad. I always get those mixed up. And 11. Okay, so now we can save. Perfect. So let's compile with function F12. Great. So we're not going to upload it because we don't have an actual touch panel. But first we need to compile this and upload it to the processor. So we're going to build this solution. And the build succeeded. We're going to upload this with USB. Okay, so if you ever get this error, what I typically do is if I get this error, I will power cycle the processor and then restart my computer, because I've found that sometimes only power cycling the processor doesn't solve the problem, and restarting my computer does. So I'm going to power cycle and restart, and then we'll be back in a second. Okay, so after restarting, it looks like it's working now. So I'm going to upload it to program 1 and upload. And then while that's uploading, I'm going to open my VT Pro project. So that's going to be in my TouchPanel folder, my tutorial folder, and then I'm going to open this. Perfect. And then we need to know the IP of the processor. So to find that, I'm going to open Toolbox. Toolbox is weird sometimes. You can't have Visual Studio and Toolbox open at the same time, so we have to wait till it's done uploading. Okay, cool. We'll close that. We'll close Visual Studio. Now Toolbox will open. Okay, so now we're going to use the binocular tool. And it looks like our processor has an IP of .1.14. Perfect. So we'll close that. Go here, hit Options, Host Settings, 192.168.1.14. And we're connected. Okay, so the projector just turned on. It's warming up. Okay, so now if I turn to HDMI, you can see it switched. You can go VGA, VGA2, SVideo, and I can shut it off. And now the projector is off. You can close that. So that concludes the RS232 tutorial for CS390 at Calvin University.